Large language models contain vast amounts of information, but today they typically remain confined to a simple text interface. To research a market, draft a report, and email your team, you have to prompt the AI for each task individually. You are responsible for carrying the data from one step to the next. But users are hitting the limit of what a conversational assistant can do. Today's requirements are more complex. People need systems that can take a high-level goal and determine the necessary execution steps independently. That complex requirement has ultimately led to the AI agent. By giving the software the ability to plan and act, developers allow it to execute multi-step workflows in digital and physical environments. This central core represents the large language model. It is a prediction engine that guesses the next word in a sequence based on its training data. To give this model autonomy, engineers wrap it in a specialized, multi-layered architecture. The first layer is tools and action. This allows the model to operate external software, like calculators, web browsers, and APIs. An API, or Application Programming Interface, is a set of rules that allows different software programs to communicate with each other directly. Next is memory. This layer allows the system to store past interactions and retrieve them later. This persistent context means the agent can refer back to a conversation from weeks ago to inform a new decision. The final layer is reasoning and reflection, often implemented through the React framework. React is a method where the AI generates a reasoning trace followed by an action. This allows the system to observe the results of its work, critique its own performance, and correct errors in real time. To stay current on how these technologies are evolving, make sure to like this video and subscribe to What Is Defined. Integrating tools, memory, and reflection allows the AI to iterate on its own logic until it achieves a specific goal. Once an agent is built, its behavior is defined by its environmental programming. Generally, these systems fall into two categories. The first is the reactive agent, also known as a simple reflex agent. This is an AI that follows specific if-then rules to react to triggers in its environment. For example, this reactive agent monitors a high-volume data stream, instantly sorting incoming files into color-coded folders based on their specific file type. The second category is the proactive agent. These operate as autonomous background processes driven by broader goals, such as optimizing a budget or increasing efficiency. Proactive agents do not just wait for a trigger, they actively monitor their surroundings to anticipate events and formulate multi-step plans before a problem occurs. Here, a proactive agent is monitoring a global supply chain. When it identifies a weather anomaly, it calculates the impact on delivery times and autonomously reroutes the shipment to avoid the storm. Shifting these tasks to autonomous agents allows systems to act preemptively without waiting for human intervention. Networked entities form multi-agent systems, collaborating on complex problems. A manager agent receives a goal, breaking it into subtasks. A researcher pulls external data. A coder generates logic, and a reviewer tests for accuracy. Once approved, the application is delivered. The human role is shifting from manual operation to the strategic supervision of these digital workforces. This autonomous architecture is expanding across major industries. Agents now optimize planting schedules in agriculture, monitor patient vitals in healthcare, and manage global retail logistics. A text prompt has evolved into a high-level command, initiating a chain of operations, redefining how we use software.